Hey friends, welcome back to the ongoing series of our IMAT Syllabus Masterclasses. We have already discussed biology syllabus, that was pretty long video, 1.2 hours, and we have covered up chemistry section, that was also a bit long video. Now today we are going to discuss physics syllabus, and this video is also going to be a bit lengthy, so let's get straight to the screen and see what we have today for physics section. So this is our physics specifications for IMAT 2024 and 2025. So I'm just generally explaining each and everything today. So let's just see what we have cooked today. So this is all we are going to discuss today. I have added lots of my notes pictures so that I can explain each and everything. Also I can explain topics, so that's why videos are getting lengthy. But let's just come straight to the table of contents. And so the basic purpose of making this class is just to explain each and everything. As you know, the Italian university that publishes syllabus, that is very general, so I'm just going to make it easy for you and try to explain each and everything that you need to study. So I will explain with each and every topic that in specific chapter what topic is it. So let's get to the so let's begin our video, our class. So let's begin our class. Just grab your hard drink and let's begin. So this is our table of content. So what I have made easiest table of content. Although if you look at the IMAT syllabus that Italian University has published in the PDF form, it will look similar to this. Like it will go like in same manner, in same order, but I have give some my additional touches and make it look more easier for you to study and understand each and everything. So the first topic that we have got in physics is measurements, and then vectors, and then kinematics, and then dynamics, and then work and energy, fluid dynamics, and then thermodynamics, waves, electrostatics, current and electricity, electromagnetism. So this is our table of contents. The kinematics and dynamics are the branches of mechanics. So this is like kinematics and dynamics is whole mechanics. So just let's begin to our slides. And first of all, who am I? Who I am. So I am Semi. I appeared in IMAT 2023 and achieved 46.2 marks in this channel. I don't know wherever you are watching. On this channel we just make some legit videos on IMAT. So this is my Instagram handle. If you have any query, if you want to ask me anything, or just want to follow me, so just go ahead, and this is my handle, Isami Kamar. So just next, first of all, the first chapter that we have is measurement. So in measurement, what you need to study. So lots of students struggle with syllabus. That's true. At when I was giving IM exam, so in which in community, each and every student was discussing like what to study in this chapter, what to study, how to study. Like people were so confused that how to deal. If you have looked at IMAT PDF syllabus, it is like very general, and it is like in dishonor or disorder manner. So it is very hard to understand that. So just if you want to study physics, just I am going to cover each and everything. Nothing will come out of this syllabus. So just first of all, in measurements, you have to do is physical quantities. What are physical quantities, what are fundamental quantities, and what are derived quantities? I'm going to explain in a while, in next slide. And what are SI units? You should know SI units of many, like whatever you are going to study, like in kinematics and dynamics, speed, velocity, and then in electromagnetic induction, like we have got electric flux, we have got magnetic flux, we have got Coulomb's force between two charges, and then we supposed to know that what is the unit of resistance, what is the unit of resistivity, what is the unit of conductivity, conductance, each and everything. So this whatever is in our syllabus, we need to know the SI units. So just SI units is at that level. And then we have got scientific notation. This is very simple and easy. You probably have studied in your like secondary school and also in higher secondary school. So this is very easy. Just go through it. There is no question seen from in previous IMAT papers, but you should study because everything can happen. So in scientific notation, you need to actually learn the rules. If you learn the rules, you are going to solve whatever he is going to ask you. You can answer it easily. Then conversion between units. So just see how it is done. So in fundamental and derived physical quantities, you need to know the definitions and significance of fundamental physical quantities. Yeah, and explanation of derived physical quantities and their interrelation with fundamental ones. Then system of units, international system of units, you need to know. Overview of technical system of unit, highlighting key differences and applications. So this is not a big deal, but you need to know these things like what is the unit of velocity, what is the unit of speed, what is the unit of acceleration, what is the unit of angular acceleration, what is the unit of angular velocity, what is the unit of angular displacement. So these things you need to know what is their SI unit. Then we have got some prefixes like kilo, mega, giga, tera. These are the things that these added to units, and then when calculations come, when scientific problems come, we cannot solve if we do not know the value of like for example pico. How you are going to solve it if he gives you in picometer and he demanding answer in meters. So now you need to put the value of pico. If you are not going to put, the answer will be wrong. So this is just like you need to know these things, milli, micro, all these things. Milli, micro and picometer, nanometer, these are the like widely used in physics. So you need to know that. Okay, then we have got scientific notation, definition of scientific notations, and then you need to know the rules, how to actually there are 4 or 5 rules you need to know. Point between, or if it is after first decimal point, like all these things. If it like 0 will be minus, the power will become minus if we go from right to left, and if we go from right to left, the power will be positive. Left to right negative, and left to right positive. So you need to know that each and everything. Then we have got this is all about measurement. Is very simple chapter, very simple. There are just, you need to know this SI units, nothing else. That's the thing. There is no vernier caliper, there is no screw gauge, each and everything is minimized. So the syllabus is pretty very simple. Then we have got vectors. So in 2023 there was a question from vectors, so you need to study vectors. I didn't study at my time. I do study. I knew all of the things, but I did not closely or practice the head to tail rules or the addition and subtraction of vectors. That is very simple, but there is some quotations and some simple tricks that we need to know, or some simple rules that we need to learn. So I did not study that, and there was one question from it. So you need to study vectors. Then vectors, first of all, in vectors you need to know introduction. There is no such introduction. You need to know actually scalars and what are scalars and what are vectors. Scalars and magnitude, vector when magnitude plus direction. So that's the thing. And then you need to know rules of addition and subtraction, and then you need to know how to add. There is biggest rule, that is head to tail rule. Vectors are added by head to tail rule. You need to know that. Conversion between units, this was just I think copy pasted from the previous slide, but that's okay. So in vectors, first of all, in scalar quantities, you need to know the definition of scalar quantity. That's very simple, and examples are mass. Mass has got no direction at all. And then temperature, we just measure temperature. We do not indicate temperature is in east direction, in north direction, or in above or bottom. We do not indicate direction to temperature. Then we have got energy, and energy is also scalar quantity. Examiner can ask you, he will give you some examples, 4 or 5 options, and he will ask you what are the scalar quantities and what are the vector quantities. Maybe he gives 11 to 12 in like 3 sets of 3 in each option, and he asks you what sets are vectors A, B, C, C, A, B, whatever the order he follows. But you need to know that you need to prepare that in according to it. Mathematical operations involving scalars, addition, subtraction, multiplication, and division. Scalars also, you need to know the addition and subtraction of the scalar quantities. Also, you need to know the addition and subtraction of scalar quantities, and then similar rules apply to vectors. You need to know how vectors are multiplied, how vectors are added, and all that stuff. If we focus on examples, that is displacement is the vector quantity. In contrast, distance is scalar quantity. Distance is scalar quantity, and displacement is vector quantity. We indicate displacement is the specific distance between 2 points. So specific distance between 2 points, while shortest, we call it shortest distance between 2 points. We are going to learn in kinematics and dynamics displacement and all that stuff. Then velocity, acceleration, force, these are all vector quantities. How they are vector quantity, we are going to discuss in kinematics and dynamics. Vectors, you need to I have explained what you need to know in vectors. Just pause the screen and look at it if you want to look. Then we have got kinematics. In kinematics, so kinematics is the kinematics and dynamics are the branches of mechanics. In mechanics, so I'm going to just generally deal in mechanics. You need to know first of all motion and rest, motion definition. Then we have got types. I have listed each and everything in next slide. Types, and I have added maximum my maximum notes in kinematics and dynamics. So we are going to explain each and everything. So it will take just a little bit longer. And then you need to know what is velocity, what is speed, and what is acceleration, what is retardation, all the types of acceleration, all the types of velocities. You will be amazed that in 2023 there will be a question from average velocity. Now I remember that's answer was 40 meter per second. I was struggling to make formula, and that's why when you have got tons of pressure during examination hall and during examination, you will forget each and everything. So you need to practice each and everything, all the formulas, all the units. This is all going to ask examiner going to ask in physics. What we do, we just memorize it, we just go through it. But that's not the situation. You don't need to do that. In acceleration, we have got some types, and it is vector quantity, its unit, and its types are very important. Then we have got equation of motions. Equations of motion are very, 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 very important. At least one question is done from these equation of motion. We have got first, second, third equation of motion. We are going to learn what are these equations, how to solve. We are going to discuss MCQs of it. But for that all, there is one question from first, second, third equation of motion. At least one MCQ. If you solve past papers of BMAT and IMAT, you will see that. And soon I'm going to solve all of the BMAT and IMAT past papers on my website samikamal.com. If you wanna look, there will be 1 month or 2-3 months, 2-3 weeks. I will slowly publish it. That's the situation. And then we have kinematics. So in kinematics, first of all, you need to know what is motion and the scalars and vectors associated with motion, distance versus displacement. Distance versus displacement. I have added my note, distance versus displacement. We are going to learn what is this, all that stuff, blah blah blah. Velocity and angular velocity. Angular velocity is uniform circular motion. Angular velocity is in linear motion, while angular velocity is in circular motion, like the motion of Earth around the sun and the motion of electrons around the nucleus. That's the angular velocity, definition and calculation of velocity, speed, all the stuff. And then we have got acceleration and centripetal acceleration. This is very important. Centripetal force is very, very important. I have arranged in my own way. That's very pretty simple. So we are going to see what I have put. So then kinematics. In kinematics, these are the very important things. Types of motion: uniform rectilinear motion. Motion in a straight line with constant speed is uniform rectilinear motion. Uniform accelerated motion, motion in straight line with a changing speed. And uniform acceleration, uniform circular motion, motion in circle at constant speed. And harmonic motion, so oscillatory motion where a body moves where a body moves back and forth around a central position due to the storing force. So this is harmonic motion. What we need to do in circular motion, you need to know the angular velocity, what is angular acceleration, it is alpha, and what is angular momentum, what is centripetal force, and centripetal acceleration. You need to actually remember the formulas of all these, like alpha is equal to v is equal to r omega. Omega is angular velocity. A is equal to r alpha. Alpha is angular acceleration. P is equal to r angular L. R L. L is angular momentum. So you need to know all these stuff. Harmonic motion is two things that are included in our syllabus. That is simple harmonic motion, but pendulum also follows. So we are going to do in simple harmonic motion, we are going to do pendulum as simple harmonic motion. So I have listed simple harmonic motion and pendulum in waves chapter. We are going to look at that. I think I did not add my notes, but that's okay. Let's go. And then kinematics. So this is our distance versus displacement. So I have made some notes. First of all, I added the definition. It is hidden because due to corner rounding, but that's okay. Rest and motion are relative, observer dependent. So that was the definition. Motion, that is the most important point. The motion of Earth with respect to Sun is 30 km per second. You need to know that. No, IMAT is not going to ask you this, but that was written in book, so I just wrote it down here. Then the main thing is distance versus displacement. So this is actual path length. I'm not going to explain very deeply. The class will get very lengthy, and I'm not going to do that. I will just make it 1.2 1.3 hours lengthy, so that would be our average. Distance, actual path length, I have read lots of notes, so this will make so this will make I have read lots of notes, so this will make if I explain each and everything, this will make class very lengthy, but that's okay. Distance is scalar quantity, vector displacement is vector quantity. That's a major difference, and its dimension are this, both are LL. Meter is the unit of both, but always remember, distance is always positive. Distance is always positive, because scalar quantities can't be negative. You need to know that. But displacement can be positive, can be negative, can be zero. On the other hand, distance can be negative, can be zero. Distance will be distance, always distance. There will be always positive value attached to it. Distance may not have unique value, but displacement always has unique value. So I have just written down that during straight path, distance is equal to displacement, because displacement is the shortest distance between 2 points. And if that's the total distance, and there is no for example, see on screen that if distance is this, distance is from A to B, from the whole half semicircle, but the shortest distance is directly straight line A to B, so that's the displacement and that's the distance. But in this case, in straight line, we have got same distance and same displacement. So in straight line, distance will be equal to displacement. But in curved path like this one, distance will always be greater than displacement. That's the thing, because distance, that's the definition of displacement. Distance is the displacement is the shortest distance between 2 points. So there is some MCQ that I have made, a multiple choice question that I am not going to explain. It will take bit longer. That I know that it doesn't mean that I remember. If you, I read, I practiced, I revised my notes multiple times. Now after test was in October, and I got abdicated in November. From November to this, while I'm recording in December, in January, just after 2-3 hours, January 2024 will start, and I remember each and everything after 3 months, each and everything. So that's the plus point. I will suggest you make your own notes. From now on, you will have 6 to 7 months, and in that month you can revise every 15 days. You just revise again and again and again. In exam, I will bet you will get 70 out of 60 or 70. You will be getting 60 and 70 marks. And then we have got speed versus velocity. Speed is the rate of change of distance, while velocity is the rate of change of displacement. That's why velocity is scalar quantity, because displacement is scalar quantity, while speed is scalar quantity, because distance is scalar quantity. Velocity is vector, and because displacement was vector. So this is the formula. P is equal to S by T. You need to remember that, and because of this formula, I solved 2023 IMAT question. This formula, this is very basic. I know most of you remember that what is this formula, but anyway, and this is the same concept that we applied in distance versus displacement. So this is the explanation. And now the best part, that is, this is like shortest thing that you need to remember. Always remember, if a right angle triangle is given to you and base and perpendicular is mentioned while hypotenuse is not mentioned, you are going to apply Pythagoras theorem. But the shortest thing is that in majority of the question they are going to give you 3 and 4, like base will be 3 and perpendicular will be 4, or base will be 4 or perpendicular will be 3. So always remember 3-4 triangle is equal to 5 without applying. If you apply Pythagoras theorem, I have applied, like here you go, I have applied Pythagoras theorem and you are getting 5 answers. So always remember 3 and 4 in IMAT chapter, and this 6 by 8 triangle will be equal to 10. So in IMAT, the question that I was talking about, the displacement, what was average velocity one, that's calculation was 6 to 8, and I just instantly put it. I think that was 60 by 80, and I made 100. So that's the thing, 0 0, and it will be added. 60 80 will be 100, 600 to 800 will be 1000. So that's the thing. Just use common sense. So you need to remember these things. These are the very great things. And here I have solved some example with statement. Statement is this: E to B, B to C. What is a body moved from A to B, and then B to C? What is distance? What is displacement? What is velocity? What is speed? So you need to find this, and this is very easy. You just need to focus. Just pause the screen and look at it. What it is. And then we have got some types of velocity. This one I was talking about, average velocity. So here is the formula: V average is equal to total distance divided by total time. And here is the one example I have mentioned, and here is the another example that I listed. This is the formula that is using in this question. I know these are a bit harder to understand these problems. I have not written statements in proper way, but on next pages I have written some statements very greatly. So the formula is 2v1 v2 divided by v1 plus v2. So this was the formula is used in this statement when we are not given with time. So you are going to use this formula. When we are given with time, when no velocity, then we are going to use this formula. This one, no, I did not write. I did not capture the picture. Anyways, but that's okay. Okay. Then the question is that if we are given velocity in kilometer per hour, how you are going to convert this? Just divide the kilometer one by 5 by 18 and you will get in meter per second. Meter per second is SI unit. You need to find everything in SI unit. So if he gives you, examiner gives you question in kilometer per hour, you are going to convert in meter per second. Just divide that thing with the kilometer per hour by 5 by 18, you will get in meter per second. So I have added some examples, and this is the another question. If the displacement is 15 meter, time is 10 seconds, what is average velocity? Just divide 15 by 10. D, V is equal to ST, F is given and T is given. Just multiply them. 15. No. If the D is 15 meter, T is 10 seconds, what is V? V is equal to S by T. Divide 15 by 10. 15 by 10 is equal to 1.5. So that's the thing. And then we have got another question. I have added solution. This is the solution. And then we have got relative velocity. So relative velocity is very interesting. So this is the situation that examiner can ask. So if two bodies are moving anti-parallel, like one is approaching another, then velocities will be added. Like if it was be moving with 100 meter per second and this one is 2 meter per second, so the average velocity, so the relative velocity will be 300 meter per second. But on the other hand, if two bodies are going away from each other, if it's 200 meter per second and it's 100 meter per second, then we are going to subtract, the relative velocity will be 100 meter per second. So I have written this thing and one example from here. And then we have got acceleration. Acceleration is the rate of change of velocity. Velocity divided by time is equal to acceleration. Acceleration will be changed when speed changes, when direction changes, or both changes. If magnitude changes or if direction changes, in both cases acceleration will change. And I have added some examples and types of it. You need to just look at these. I'm not going to explain. And then we have got velocity time graph. That's the important thing. It's very, very important. We need to know the slopes of each and everything, gradient, and I know this will just making class uninteresting. Your interest is going. I'm going to just what is slope, what is gradient. If you know it, you will be like getting my point. But if you don't know it, you will be like just going to turn off my class. But that's the situation. Okay, velocity time graph. You need to know the slope. Slope is what? Perpendicular by base. Y-axis divided by x-axis. That's very basic. You would have probably studied in your secondary and high school in both. V by t is equal to alpha. And this is velocity, perpendicular, and base is time. V by t is equal to slope will be acceleration. So all these things are acceleration. How? Let's see now what are the cases I have mentioned here. And if you want to find area, just multiply y-axis, x-axis. Vt is equal to s. That's the area of this graph. And if you want to find the slope, then y-axis divided by x-axis. V by t is equal to a. In every case, there will be some sort of formula if you remember all of the formulas. So here is like in first one, this one. So in first one, slope is 0 because the body is at rest. V is constant, uniform. Body is moving with constant velocity. Constant velocity is not changing. There is no now velocity. Velocity is this line. Now velocity is coming down, not up, not picking up. Just time is passing by. Time is passing, but velocity is constant. So slope is 0. Because we have got velocity constant. Velocity is Vf minus Vi. So if velocity V final was 5 and initial was 5, we are getting 0. Y by x, y is 0, then x will be probably get 0. Okay, then we have got the second line. What second line indicates is second line is also constant. So the velocity in second line, the velocity is increasing uniformly. Velocity is increasing uniformly, and all this stuff. This is very like basic. I'm not going to stress on this, and this is very important. Like sine, it's hidden. Sine 0 is equal to 0. Sine 30 is equal to 1 by 2. Sine 45 1 by under root 2, and sine similarly. These you need to remember all these. And some I have written some from examples. Sorry, MCQs. These are very, very, very good MCQs. Just read it, you will understand. And then we have got some more MCQs, and then we have got equations of motion. So in first equation of motion is Vf is equal to Vi plus At. Some people write it Vx and V initial is V naught. So in like I think A levels Pearson. But I have learned in my high school Vf is equal to Vi plus At, so I'm using this. And it is first velocity is independent of displacement. There is no displacement. Second is independent of final velocity. There is no Vf, and s is equal to Vit plus half At square. That's the thing. And the third one is 2s is equal to Vf square minus Vi square, and it is independent of time because there is no time. So if time is not given and each and everything is given, you are going to use 2s is equal to Vf square minus Vi square. If final velocity is not given, then you are going to use this one. So it depends on situation. Just remember them, and then that's the thing. And limitation applicable only for straight line motion. Equation of motion are only applicable for straight line motion. So these are some examples. So I have written some two cases. If in one case body is free falling, and in second case body is upward moving. So in upward case we are taking gravity negative, and in downward case we are taking gravity positive, and it is adding. So this is like calculation. This will take like 30 minutes or 40 minutes to explain each other, so I'm not going to stress. Let's move on to next slide. So this is reminder, 2 more classes. I have made biology one that is on available on my channel, and the chemistry one that is also available on my channel, and this is my channel handle. Just go and subscribe it and see the videos. So this is the biology one. This is pretty awesome. And then this one is the physics one. This is pretty awesome. I just uploaded yesterday. And then this is our handle. Just go and watch it. If you do not understand, then how to watch, just go to my channel. There is playlist of IMAT Masterclass, Syllabus Masterclasses. So just watch that playlist. And then that was our kinematics. Now move on to dynamics. In dynamics, we are going to learn physics, Newton laws, first, second, third, and then momentum, and then law of momentum. Then collision, elastic collision. This was in 2023 there was one question from collision in one dimension. Elastic collision in one dimension, there was one question. So this is important. We need to practice. And I did not solve this MCQs. I just left that because I did not remember formula. We are going to on that formula. I have it in my notes picture. That is very big formula. Let's go. And then in dynamics, you need to know the concept of force. And then force is also vector quantity, because F is equal to ma. I have written here, and acceleration is vector quantity, due to which force is scalar quantity, vector quantity. Sorry, mass and second law of dynamics. These things that you need to know. Impulse and momentum are important. I have it in my notes picture. We are going on that in a while. Then conservation of momentum, law of conservation of momentum. That is the law that I have added, and we are going to study it. Momentum and force and angular momentum. That's the circular motion. I explained earlier that what you need to know, what is angular acceleration, what is angular momentum, what is angular acceleration, what is angular velocity, all that stuff. So now here we have got 3 Newton laws. Newton laws are first law, second law, and third law. So in first law has got just limitation only for bodies moving very slowly. First law is applied on those motions. So what first law says, that defines force. First law defines force, and V is equal to 0 because body is moving constantly. Because body is moving constantly. When body is moving constantly, there is no change in velocity. When there is no change in velocity, I explained earlier, Vf minus Vi. If the body was moving initially with 5 meters per second and finally final velocity was 5 meters per second, then we are going to subtract that, because Vf minus Vi equal to 0. So that's why acceleration will just go to 0. And then F net is equal to force will be 0. Equilibrium, this is also known as law of inertia. And there is a second law. Second law is very important, because its F is equal to ma, and its SI unit is Newton, while its SI unit is Newton. And then if we convert, Newton is also SI unit, and if we convert it, if we make it in further derive it in drive unit, we are going to mass is kg and acceleration is meter per second square. Here you go, kg meter per second square is equal to Newton. And then here I have listed some 3 cases, like if mass is constant, then force will be directly proportional to acceleration, and if A is constant, F is directly proportional to mass, all that stuff. And then third law is force always exists in pair. This is third law of motion. Examiner can ask you this. Force always exists in pair. FC, if it's centripetal force, there will be always be centrifugal force. Walk, swimming, all that stuff, writing, running, that all happens just because of third law, because we do action and in return we get a reaction. F action is equal to F reaction. Action and reaction act on 2 different bodies. Always remember, not on same bodies. If action occurs on one body, and reaction will always occur on 2 different body. And then there is our momentum. Momentum is the quantity of motion. Momentum's formula is P is equal to mv. You need to know this, otherwise you are going to make a mistake in your exam. P is equal to mv, and product of mass and velocity is our momentum. So this is our just momentum. And then in momentum we additionally have got in momentum we additionally have nothing, just this is just we have got just this type of momentum. So then we have got direction, momentum is also vector quantity. Always remember it. Okay, always remember it. Momentum is vector quantity. The momentums as a unit is Newton second, kg meter per second, p is equal to mv. So I have written some as 3 cases, just like the law of the Newton third's law, and this is our its mathematical form. I have derived further, like mv. I have put it vf minus vi divided by del t. This is the acceleration. It is equal to acceleration. A is equal to vf minus vit. Sorry, this is Newton's second law of motion. F is equal to ma. We have put it vf minus acceleration. We have expanded. A is equal to del v divided by del t, and del v is equal to vf minus vi. So just multiply mvf minus mvi. Mvf is equal to final momentum, mvi is equal to initial momentum. So vf minus vi del p divided by del t, and that's 4. Always remember, rate of change of momentum is force, and we are going to discuss some a little change in it in the statement, that will be impulse. Rate of change of momentum by time. So I have added one formula, one example here. This is our law of conservation of momentum. P is equal to constant, momentum is equal to constant. It means that final momentum will always be equal to initial momentum in an isolated system. That force is equal to 0, because del p is equal to 0, p is constant. It means that pf minus pi is equal to 0, del p is equal to 0, and it means that force is equal to del p divided by del t, then force will be 0. So all that stuff I have added the example, bullet gun example. So it's this is the mathematical form. If you want to look, you can look at. And then we have got impulse. Impulse is when a very large force acts on a body for a very short interval of time. So the statement is, change in momentum of body is called impulse. Change in, only change in. Rate of change of momentum is force. Change of momentum is impulse. This was the mistake you are going to make in examiner. Always there are high chances that examiner can ask you. So I have added the example that if a person jumps on a hard floor, if it means that if time is very low, time is small, then the force will be higher. Force and time are inversely proportional to each other. So if time is lower, force will be higher, so the person will get injured. And if person, like this is the rubber, if person falls on it, time is little bit higher, so the person will get little force. And this is water, the time is very high, like a person will drop here and it will take very longer time to reach here, so the force will be minimal. There will be no like force act on it. That's why people drop from high. So this is our conclusion. This is the question that IMAT 2020 in 2023 appears. So occlusion has got 2 types, elastic occlusion and inelastic occlusion. In elastic occlusion there is kinetic energy, momentum and total energy all remain conserved. It means that initial and final will be same. No sound, no heat. That's the ideal case. But in inelastic occlusion, kinetic energy does not remain conserved. It will convert into sound energy or heat energy. There's some, I have added some examples, but the one that I am going to ask you is elastic occlusion in 1 dimension. This was the formula that solves that question. So I just forget the arrangement, proper arrangement. Time was very limited. I did not want to focus on it. I just went on mathematics section. Otherwise, I have got the 46.2 would not be possible. So if I remember this formula, I do not know in IMAT exam why I didn't practice this in my home national exam. I was practicing it very lot, but that's luck. Yeah, always. It's luck and it's hard. This one hard. And this is just Newton's law of coefficient of restitution, or Newton's law of restitution. So E is equal to V2 minus Vi divided by U1 minus U2. That's the final, and this one is the initial one. So just study from Pearson book. You will understand how to apply these, or from your national book, wherever, from your high school book, from wherever country you belong. Do not look for books. Just study from your high school books. Okay, work and energy. Work and energy is also good. You need to know work. What are the types of work? Like work is work done by constant force, work done by variable force. We are going to look at that. Work, the formula of work is W is equal to Fs force multiplied by displacement or distance, whatever you call it. It's displacement actually. Conservative forces is conservative forces and non-conservative forces. We need to know that energy, kinetic energy, types of energy, kinetic energy and potential energy, both of the formula. Kinetic energy is equal to 1/2 mv square and potential energy is equal to mgh. Then we have got power. You need to know the formulas of power. That's very, very important. Let's go to that. And here we have got work done by constant force. Work done by constant force is equal to W is equal to FD. And here is some, I have added some critical points. I'm not going to explain what is cos theta and what is sin theta, all this stuff. And this is the dot product of force and displacement. Work is scalar quantity. Always remember, dot product, both of these are vector quantities, but work is scalar quantity because that's the dot product. If it would be cross product, that it means that work would be work would be vector. These are the vectors. You just study these things, how vectors, what are the what quantities are vectors, what are scalars, all this stuff. And then dependence. So I have added the work will be 0 when 30%, when 50%, 60% and when 90%, 180%. I have added some theta, cos theta 30. I just show you in just previous slide. Of course, cos 30 is equal to, just put it here and you will get 80% of work, 86% of work. So that's the thing. Then we have got work done by variable force. So these are the conservative field. I'm not going to explain. This will take very, very longer. So conservative fields. Let's discuss what are conservative field and what are not. Gravitational field, electric field, elastic spring force are the examples of conservative field. In this field, work done is independent of path followed. Work does not depend on path followed. If you, for example, if you see it, if you go from here to here, the work will remain same. If you go from here to here, the work will remain same. Work does not depend on the path followed. But in non-conservative field, work depends on path followed. Frictional force is the MCQ. That's the important. Frictional force is non-conservative force. I think in IMAT 2023, no, in I think a past IMAT paper or BMAT papers, there is one question related to it. Frictional force is non-conservative force. Then we have got work done graphically. So I explained how work done graphically. I have added some how to calculate work in square, rectangle and trapezium. I have written all the formula. This is the formula in trapezium. Follow this formula to calculate work in trapezium area. Sorry, how to calculate area in trapezium. Then work done by gravity, where body is moving downward and one body is moving upward. Like when body is moving downward, the displacement direction is downward, and gravity is downward. But when body is moving upward, displacement is upward, but gravity always acts on downward. Always remember, gravity always acts in downward direction. Then we have got energy. What is energy? Ability to do work. The energy as a unit is joules. If we drive it, kg meter square per second square. Mechanical energy is of two types: kinetic energy, potential energy. So I have derived the equations in terms of momentum and in terms of momentum, and potential energy in terms of gravitational potential energy and elastic potential energy. So these are the formulas. You need to remember each and everything. And if like momentum is increasing 20%, and if kinetic energy is increasing, what would be kinetic energy? So this is the formula that you need to implement. And similarly, I have added two examples here. Then we move on to power. Power is very important. You need to know the power formula of power. P is equal to W divided by T. The SI unit of power is watt, and we also measure in horsepower. Horsepower is 1 horsepower is equal to 746 watts. And then for this is the very widely used formula of power also. P is equal to FV. We are also going to study power in electricity. That is also important in terms of what are the formulas of power in terms of electricity, in terms of resistance, in terms of voltage, in terms of electricity, current. We are going to do that. And then efficiency. I have just added some questions, MCQs. If you want to look, if you are enjoying my notes, if you want to look at that, that's absolutely free. Just go to that video. This is my handwritten notes. I explained how you can download them. Just go to this, and I have explained how I prepare how you need to study these notes in 5 minutes, 4.5 minutes. just go there, and then if you want to download it, just go to semicomer.com and search IMAT notes, or on home page you will see my notes, or check the video description, there will be link to my notes, or just simply Google it, Semicomer IMAT notes, or IMAT notes Semicomer, whatever the query you put, handwritten notes Semicomer, whatever the situation you put. But anyways, then go to fluid mechanics. This is also very important. One question from this chapter. So you need to know the basics like density, hydrostatics, hydraulic lift, all that stuff. And then principle, we have got Pascal principle, Archimedes principle, then we have got equations, Bernoulli's equation, and equation of continuity. Let's see it. Fluid dynamics. In fluid dynamics, you need to study density and compressibility of fluids. Gases and liquids are compressible. Liquids are not compressible, incompressible. Solids and liquids are incompressible. That's the you study these properties of liquids, gas, solids in chemistry. I have explained already in chemistry class. Just go and look at that. Kinetic molecular theory explains what are the characteristics of gases, liquids, and solid states of matters. Then we have got density and compressibility, hydrostatic pressure principles, the Pascal, Stevino, and Archimedes principle. You need to just learn that. Just learn these. I in my high school, or I think I did not study. This was not included in my national exam. So what I did then, I took separate lectures from Lecturo that I have shared in my video. That was the best resource to follow the study or take lectures. Also you can follow Khan Academy, but Lecturo is also good. It's premium, but you can just look at YouTube. There are like hell lot of lectures on YouTube regarding these things. Just study these. And then we have got like viscous forces and liquids, ideal fluids, and Bernoulli equation. These, they're like, here you are going to, examiner is going to ask questions from Bernoulli's equation, from equation of continuity. I have taken notes of it, but I did not mention it. I will share on my website, or what I mentioned here, I will share on there. I added very deep points from Lecturo. Okay, then if you are enjoying, do subscribe to my channel. This is my Instagram, my channel handle. Just subscribe it. And this is my Instagram handle. If you want to ask anything, just go ahead. Then we have got thermodynamics, basics. You need to know the basics of thermodynamics, temperature versus heat. I have added my notes. We are going to look at that, and I'm going to explain. Then you need to know the laws, first law, second law. There is also zeroth law. I'm going to discuss. That's not mentioned in IMAT syllabus, but you need to know the first, second law. And then we have got specific heat capacity. This is very important. Here, from this topic, there are going to be questions. Question will be problems, calculations are going to be made in this topic. Formulas, we need to remember some formula. Let's go ahead and see what we need to know. Concept of temperature and thermometers, concept of heat and calorimeter. Calorimeter is like from chemistry. That's not included, but they have added in physics. Just study that. I did not study in either in high school. I don't know anything about calorimeter. I just know in one calorimeter there are two types of calorimeter. I do not know what is I know that I did not study. I just listened something about calorimeter. There is some direct calorimeter or indirect calorimeter. In one calorimeter, direct or I don't know. There is volume constant, and in second one pressure is constant. I just know these things, nothing else about calorimeter. Then heat propagation modes, convection, conduction, and radiation. Thermal chemistry and specific heat, this we are going to study. Changes of state and latent heat, this is also very important. Ideal gas laws are from actually chemistry, Charles, Boyle's, and then Avogadro's law. Just study there. No need to study here. First law of thermodynamics and second law of thermodynamics we are going to cover. Okay, first in thermodynamics, what is temperature and what is heat? This is the very important thing. Heat is another form of energy. Then and its unit is energy, joules, same as heat. But temperature is measuredness of hotness and coldness of body. This is the average kinetic energy of particle. and its units are in SI, its unit is Kelvin, non-SI units are Celsius and Fahrenheit. And this is the formula how you can convert from Celsius to Fahrenheit and Kelvin to Celsius, or Celsius to Fahrenheit, all this stuff. So I have like converted from Celsius and Kelvin calculation. This is the formula. I just use this formula like temperature name in which you are going to convert, and its freezing point. I have mentioned the freezing point somewhere. Here is the freezing point. So in Fahrenheit we have got freezing point 32 Fahrenheit just mentioned here, and then in which you, for example, if we were converting from Celsius, just put 0 as freezing point and boiling point as 100 degrees centigrade. Just rearrange it and multiply it, all the stuff, and you will get just like this. So zeroth law of thermodynamics is before, when bodies were separate, this was the result, like 100, 200 and 100, 0. But when bodies were connected, 100 is like temperature becomes same in each body. 100, 100, 100. Temperature flows. Heat flows. Temperature does not flow. Temperature is just my awareness. We have studied. Heat flows from one to another. So this was the question, and I have added like wood and steel have same temperature by 50. If environment temperature is 50 degrees centigrade. Now, if you prefer like if you sit on steel, you will feel hotness. But if you sit on wood, you will not feel hotness. What was the reason? So this is the question. I have added explanation. So the explanation is both have got same temperature, both have got 50 degrees centigrade, but steel feels hot because the temperature heat flow rate in steel is higher, while in wood it is very, very slow. That's why we do not feel very, very hot. But on the other hand, if we sit on steel, we just get burned. We get burned on bum. Sorry. No, we do not need to use foul language. Okay. And then we have got types of system: open system, closed system, and isolated system. Open system, heat, matter, both are transferable. So just study these. This is very basic. First law of thermodynamics, it is law of conservation energy. Always remember law of conservation of energy. Momentum. Law of conservation of momentum is also law of conservation of energy, and we are going to study Lenz's law, that is also law of conservation of energy. So just remember this. So sign of convection, this is very confusing, especially in case of work. In physics, work done by system is positive, but in chemistry, work done by system is negative. I just remember the chemistry one, I just convert it in physics. I just remember the physics one, like work done by system is negative. My all mates from high school confused in this thing, and I do not. I remember one from chemistry or physics. From chemistry, like there is a difference in chemistry and physics. Chemistry, work done by system is negative, while in physics that is positive. Just remember, work done on the system is negative in physics, while positive in chemistry, electrochemistry. Okay, work done. This is the formula, that is del Q is equal to del U plus del W. This is the law of first law of thermodynamics. First law of thermodynamics is del Q is equal to del U plus del W. Then we have got applications of first law, isothermal, isobaric. These are very simple for graphical, very, very simple. Just focus on and just take lecture or just study from book, you will understand. Then this is the Molar specific heat. So this is the formula that you need to know. Q is equal to Cm del T. So heat, C is the heat capacity, Cq by del T, or Cm is heat capacity. And here how we are going to use, I have added like these are the formula: molar specific heat for isothermal process, molar specific heat for adiabatic process, molar specific heat as the constant volume. So just study and just focus on these things. And this is also important: Cp is equal to Cv plus R, Cp minus Cv is equal to R. And there are like questions that I added. R, what would be gamma? This is gamma for mono. Where I listed mono, I think this is the monoatomic gas. Gamma for Rm, gamma for monoatomic gas will be 1.6. Rd for diatomic gas, gamma will be 1.4. For polyatomic gas, 1.29. These uses in if you studied I think it's not included in physics. In sound, speed of sound, there is like question that asks, that says sorry, Laplace correction. Laplace used the gamma for monatomic, so you just need to remember these. Newton's correction by Laplace. Newton were corrected by Laplace. Newton was getting 281 meter per second speed of sound in air, while Laplace corrected it and he got 332 meter per second because he used the adiabatic process while Newton was using isothermal process. So just these all you need to study, bro. You need to study. That's why students say that we lag in physics. Physics is very hard. We do not understand that. You need to study. I hated physics in early stages, but while studying for exam, I was thinking that I do not know physics. I lag in physics. I cannot attempt a question. But when I was applying for my pre-enrollment, I looked at my high school DMC and I just look at, and I got in my high school, out of 200 I had got to 185 marks, 185 or 190 something, 185 or 190. There was a thing I got this. I was just amazed that why I think that I am very bad at physics. I am very good. That's why I have got very great marks. So just let's think positive, in a positive way. You know that if you lag in physics, just focus on physics and focus on chemistry, focus on physics, focus on biology. You will just ace it. Just think positively. So this was the wave. I just added simple harmonic motion and pendulum. We already discussed. I did not add in my picture notes pictures, and I just here I just did not add it. I do not know why. I think this will get very lengthy. That's why I did not add it. So in electrostatics, charge at rest, electricity, charge in motion. So we are going to just study in consecutively. Electric charges. You need to know electric charges. What is positive charge? What is negative charge? And what is electric force between two charges? Coulomb force. Coulomb's law. Coulomb's law is very important. I have added Coulomb's law just a little bit ahead. Then permittivity constant, epsilon naught, epsilon relative. You all need to know how to calculate what the value depends on Coulomb's law. Always remember, Coulomb is mutual force. It depends on both charges. Product of charges does not depend on single charge. If we are measuring between two charges, then if on one charge force is like 10 coulomb, then on other charge there will be, that would be like 10 coulombs. That not happen like on one charge it would be 5 and on another 10. That's not a thing. It's mutual force. And in IMAT 2020 there was one question from Coulomb's law. That was a bad thing. And then I like corrected it. I attempted good. Yeah. Electric field. You need to know electric field. Then capacitor. Capacitor is very important. In capacitor you need to know what is capacitor, capacitance, what is capacitance, what is farad unit actually, and then the combinations of capacitor, parallel capacitor, and then series capacitor. So you need to know energy in capacitor, energy stored in capacitor, energies. Just add, I'm going to add more point. The energy that stored, capacitor stores energy in the form of electric field. Is the thing. And these are the topics you need to understand. You need to study electric charges, force between charges, and Coulomb's law. Coulomb's law is actually force between charges. Coulomb's law describes, there is limitation of Coulomb's law though. Electric field and potential. I think I made mistakes of spelling. Here is Coulomb's law and here is Columbus law. Yeah, you did not notice it, I know. Electric field and potential, potential difference. Electric field and potential difference, you need to know. Equipotential surfaces, you need to know what are equipotential surfaces, what are the character properties of equipotential surfaces. Dielectric constant is actually C in capacitor. Capacitance as capacitors, one capacitance increases, one capacitance decreases. By putting dielectric, its capacitance increases, while not putting conductor, its capacitance decreases. Electrostatic energy, series and parallel configurations, combinations of capacitors. This is Coulomb's law. F is equal to K Q Q. Oh, sorry, this is not. This is actually Coulomb's law. K Q divided by R squares. Okay, then we have got electricity. In electricity, you need to study what electric voltage, what is electricity, moving charges are electricity, what is conventional current, what is electrostatic current. Conventional was electrostatic, like from high potential to low potential to high potential, electrostatic current. Then you need to know what is resistivity, rho. Resistivity is rho, resistance is R, and resistors, what are resistors? Combinations of resistors, parallel and series combinations. Ohm's law. In Ohm's law is equal to V is equal to IR. V voltage equal to I current. R is resistance. R is equal to 1 by G. G is conductance. You need to know. Kirchhoff's principle is also important. I did not study at my time Kirchhoff's principle. I just hate these Kirchhoff principles. You need to know what crystal. I think crystal first principle follows law of conservation of energy. No. First follows conservation of charge, and second follows conservation of energy. You need to know that. I do. If I'm correct, I don't know. Work power and Joule effect. You need to know Joule effect is also important. Direct and alternating current. Direct and alternating current. Here is the question: which device converts alternating current into direct current? And what device converts a direct current into alternating current? Alternating current into direct current. Which device converts? That is what. Just say it, or I will answer it. Okay, and that's your question. I think there is whole chapter on it. You have studied in your high school. Okay, then period and frequency, and then we have got electromagnetism. In electromagnetism, you need to know about electromagnetism, electromagnetic induction. I have it in my notes. Let's go to that. What topic you need to study in electromagnetism and electromagnetic induction. So in electromagnetism, you need to study what is magnet, how magnet attracts, how magnet repels, what is actually how magnetic attracts and magnetic repels. These properties, south and north poles of magnet, all this stuff. When current, what is electromagnetic? How magnetic force can convert into electric field. It means that if we are going to study actually alternating generator, AC generator, alternating current generator, we are going to study it. So I added, this is the Ampere's law, you need to know. So I added something like if body both moves upward, then there will be attraction between them, and if body one is moving upward, current is flowing upward, and in one the current is flowing downward, the body will repel. Yeah. Okay, then we have got 4-secton current carrying inductor. This is also important. F is equal to I B sin theta. You need to know that. And here is the vector form of it, and there is the unit of magnetic. What is this? B. I have written multiple names of it. It is what we call it. I know it. Its unit is Tesla, and it is magnetic induction. It is magnetic force. No, F is magnetic force actually. B is magnetic induction and magnetic. I think I have added multiple names of it. Let's go to another second. And here is B is electromagnetic induction, magnetic intensity, magnetic field strength, magnetic density, all this stuff. And you need to know magnetic flux. Magnetic flux is 5B is equal to BA. In electricity, you need to know about electric flux. That is equal to here what is equal to EA. EA. 5B is equal to EA, I think. But just correct it. I do not remember it right now. So here are some calculations. And force on moving charge, Fe, this is also important. F is equal to QVB sin theta. And you need to know the charge to mass ratio if you want to find it. That would be great. And here are some 3 cases of it. If what would be path if the angle between velocity and QVB sin theta, V and B are vector quantities. So if the angle between V and B is 90 degree, then the body will move in straight circular path. And if I had it as multiple, there are three cases. Helical, this is the path helical, when the theta will be greater than 0 but less than 90 degree, there will be helical. I added reasons why each and everything is shown by arrows and all the stuff. What is Lorentz force? Lorentz force is V is equal to E by AB. Velocity is equal to E by B. All that stuff. You need to know all these things. I cannot explain. This is the end of class and I'm just getting I'm not getting anything. I'm energetic. I can explain. I can do 4 to 5 consecutive classes, but that's not true. I do not want to make it lengthy. I think this is like it is getting very lengthy. Okay, that's it. Okay, but let's go. Electromagnetic induction. In electromagnetic induction, you need to know how magnetic force converts into electric force and electric current and magnetic effect. Both of these, electromagnetic, electricity and magnetic effect, all these. And UCMF, when a conductor is moved in a magnetic field, a potential difference is created at the ends of conductor. This potential difference is called induced EMF. So induced EMF, you need to know. I have added some critical points. Yeah. E is constant, so it is independent of IR. Always remember one point in physics, that constant, whatever the if proportionality removes and equal sign comes, and whatever the constant is added, that does not depends on both of the terms from where the proportionality removed and constant added. Constant is always constant, that cannot depend on. So this is the question, like Q is equal to CV. C is the constant in capacitance. Capacitance is constant. So they say that if charge increase 2 times, what would be voltage? So capacitance current Q is equal to CV. Charge Q is charge. Q increase 2 times. What would be capacitance? So it means that if Q increase 2 times, voltage will increase 2 times, because constant C is constant and it will remain constant. 2 will cancel and C will constant. And then Faraday's law of electromagnetic induction, that is very important. For Faraday's law of electromagnetic induction is EMF is equal to N phi B divided by del T, and its direction was indicated by Lenz's law. So you need to know Lenz's law. Lenz's law is law of conservation of energy. I was saying that, and used to find direction of current that is produced when applying current in magnetic field. So you need to know each and everything. Just study. You need to actually study. The direction of induced current in a coil is such that it opposes the cause which producing it. So this was Lenz's law. And then we have got AC generator. So AC generator is mechanical energy into electrical energy. Faraday's law, torque acting on current carrying wire, mechanical energy converted into electrical energy. I think everybody has generator in his house. That's annoying, it sounds, but AC generator converts mechanical energy into electricity. AC current. It's AC generator. It means that it would be alternating current the generator will produce. Transformer, I think the question appear in IMAT or no. That was, I think, in past papers. In what rings used in AC generator? Slip rings, split rings, all this. So here we have got, I think, split rings. Yeah, slip rings, split rings. I don't remember. Just look at these. I think I did not mention it here. Okay, then we have got transformer. Transformer is very important. Transformer, you need to know what is transformer. Principle of transformer. Transformer principle is mutual induction. Study mutual induction separately. Mutual induction, and the other one is inductance. Study both of these separately, and remember the units, Henry, all this stuff. And then transfer does not change power, phase, time, frequency. Transfer does not perform any work on DC cells or battery. The work will be zero. Transformer cannot perform work on it. And transformer disobeys Ohm's law. V is equal to IR is disobeys by transformer because heat produces in it. And Ohm's law is that temperature will remain same. So these transformers have two types: setup transformer and step up transformer, step down transformer. In step up transformer, the rounds in number of turns in secondary coil will be greater than in primary coil. This is the primary coil and this is secondary coil. So just study this. And for this is the step down transformer, and for ideal transformer, P input P initial P input will be equal to P output. That's the ideal case. This is not true because power converted into heat temperature. Then this is the transformation ratio I have added for one for step up and one for step down. You can look at it. And then we have got efficiency for transformer. This is the I added on MCQs. And energy losses in transformer, eddies current in hysteresis loop. Eddies current produces in coil. In this is the round cyclone. This is the eddy current, and we measures H is equal to I square RT. This is the heat we measures by it, and this heat production is minimized by using laminated sheets in between two coils of transformer. Between two coils we used some sort of heat, and insulator thing. And we have got hysteresis loss. I have explained why iron is used. Actually, why this was a thing. Iron is used in transformer instead of steel, because there was a reason that steel hysteresis loss is very high while iron is less, and its steel magnetizes and demagnetizes very slowly, while iron demagnetizes and demagnetizes very quickly. It is ferromagnetic material. So this was the thing. Energy waste in steel is I added it. It just removed by hiding, tilting or rounding it. So this was our physics masterclass. Just rate it how you like it. If you liked it, just like the video. That will be very great for it. And if you have come across this point till this last, put green emoji, anything, and green apple. So I think I just get to know that you have you are curious about your IMAT exam and you think my videos are valuable. So if you love it, just thank you for watching. If you want to ask anything, go to iSemikamar.com, iSemikamar on Instagram. And if you want to get some resources or free resources, just go to semikamar.com and just consult description for notes and books. And if you want to join IMAT community, there is my WhatsApp community, IMAT Nerd. The link will be in video description. You can join that. And thank you for watching. See you in next video. Till bye bye. If you haven't watched biology and chemistry 1, go ahead and watch it. Bye bye.